And we are live. Okay, let me just start this really quick. Myself in the top corner over here. Okay. Welcome. This is 3D Printing and Introduction brought to you by the Orland Park Public Library. I'll just let this kind of sit for a little bit just to see if there's any more joining in, so I'll get started and everybody kind of gets all thrown off. Well, this is 3D printing. It's fairly self-explanatory, but as I kind of go along, then the things that may sound complex or anything that sounds like may be too difficult to do or comprehend, it's very straightforward. So I'll start in a little bit so everybody can float in. So I'll give it another minute. Okay. I'll just get started right now. So welcome, this is 3D Printing and Introduction. What is 3D printing, you may ask? It's also known as additive manufacturing. It is a form of digital fabrication using a computer-controlled tool to make any physical object. So what that means is that this machine is operated by a computer itself that's built into the printer itself that knows where to put the pin specifically or leave the extruder or how high or how hot, or if the extruder is going in completely or if there's a jam. So that's what that means. That prints and is a physical substance like plastic, building one layer at a time, creating a 3D object. So what that means is that once you make the file, as we're talking about later on, that as the needle points downward, and then as it extrudes from the bottom, as it kind of rises, that it makes kind of one layer at a time. So then after it's done or close to being done, it'll make a 3D object as it kind of layers up, as it's kind of running around. And designs are created using CAD software, which stands for computer-aided design. And Thinkorcad is for beginners, and Sketchup is for intermediate users, and Blender is for people that understand it completely and then know kind of what to do. So what I'll do is I'll go into each one of these later on, just so there's no kind of distraction focus from the PowerPoint. And then when I go to it, when I go kind of a hands-on, I'll show each one of those websites and then show what each one kind of looks like and what it offers. And the prints are generated from STL files, which is stereolithography, which means that instead of what people think is that they can use a JPEG or a PNG or something like that and then just make it from that, what it sets it apart is that this is a specialized file that once you put it into the software, as well as the printer itself recognizes those specific files only. And STL does not contain color information. So what those meaning is that if you're using a program to make it before you throw it into the 3D printer, you're not using like a template or something. And instead, what it does is that it doesn't recognize a specific color. So what if you open a program and then you make it and you're like, oh, well, I want to have green or black or orange or anything like that. It doesn't come out that way unless you actually have the filament that matches that specific color if you choose so. Right now, we're going to go into the terminology, which is very extensive. So what we'll do is first is the brands of 3D printers. As you can see on the top right here, there is Makerbot, which is what we use at the library over here for are 3D printing. There is the LulzBot, Robo, Maker Gear, Flash Forge, Ultimaker, Cube, etc. So later on too, while I show the websites, I'll show those specific different models so then you can see the difference in height, width, and what each one does. And then there are many different 3D manufacturing services, whether it be Strass's, diversified plastics, etc. So it's different services as far as like what it uses and what can be made from. Then there's filament. Filament is it's the material that's used to make the 3D objects within the 3D printer. And then there's two different types of material, which is, and there's another one that's not listed, but I'll explain it afterward. There's ABS, which is short for acrylonitrile styrene, which is a thermoplastic used for 3D printer material. And then there's PLA, which is a biodegradable thermoplastic polymer made from plant starch, which is used as a 3D printer material as well. And then there's also PVA, which is a similar thing, but instead it could be used as well as PLA, which is the two more popular kind of filament types. So with PLA, that since it's biodegradable, so then if you say you use a base and you need something that stands tall and then you want to kind of put it down, you can actually, if you want to remove the base of it so then it prints correctly, you can actually throw it into something like hot water or something, and then it'll actually degrade a part of it. So then you can actually get that piece off instead of having it stuck at the base. And an extruder is a group of parts which handles feeding and extruding of the build material, and it consists of two assemblies, a cold end to pull and feed the thermoplastic from the spool, and a hot end that melts and extrudes the thermoplastic. So what that is that when you go to a 3D printer, or if you own one, if you decide to use one, that the filament itself starts off as this like thick material, this thick plastic. So then it's kind of it's winded up kind of like wire in a way where it's hard. So then once you actually fit it into the 3D printer, it actually loads it. And then when it actually extrudes, it heats up the extruder. So then when it disperses that hard plastic material, it comes out as liquid. So then as it disperses and makes the 3D object, it actually hardens once it's completely cooled off. So then there's no kind of headaches about that. And then there is a thing called overhang, which is part of a 3D model without any support below it. Parts that protrude at any angle over 45 degrees are generally considered overhangs. So what that means is that when you make a 3D project or a 3D model, is that it needs a support sometimes depending on how big or what kind of size the object is. So then when it comes down, it's not going to come out like lopsided or anything. So that's why there's such a thing called overhangs. Now we're going to talk about these, and then here's kind of a visual representation. So as you see, the filaments come in many different colors and different styles. And then as they kind of see right here, they're kind of like what you see like kind of ropes wrapped around. It's kind of like that, but instead it's the hard, thin plastic. So then they come in many different things. They come in either be opaque or transparent, and then you can kind of use these as you kind of go along. And then the extruder is kind of like this, where there's two kind of pins right here. And then what happens is that, as you can see, the wires kind of coming into the extruder part right here, and there's like fans coming right around here, where once you feed the filament through, it goes through this tube and it kind of gets fed through here, and it can either be cooled off or heated up as it gets to the extruder tip over here. So then sometimes if there's like a pointed edge or something, that's why I always kind of tells you what to do beforehand to make sure there's no kind of jam, because sometimes if you feed it in a specific way, sometimes the filament actually itself gets jammed or something like that, where the part kind of gets stuck. And then sometimes if you want to take it out, it could get stuck by the extruder. And then if you want to fill out a different color or something, if you pull it out and replace it, sometimes it gets stuck, and then without it being heated, it can kind of damage the extruder. And as you can see right here on the bottom right here, this is what overhang kind of looks like, where you see like the 45-degree angle as it kind of goes along. So you kind of see like a kind of a different shape right there. And then next is support material. 3D models that have a large overhang or gap between parts require a short material to be printed, as it would be impossible to print into thin air, which is kind of self-explanatory. The support material is removed once the 3D print has finished in order to reveal the final print. So what that means is that majority of the time, whenever something's being printed, it needs a base for it, so then it doesn't get stuck, or it needs kind of a base for it to be able to print out, so that it stands upright, so it doesn't come lopsided as it kind of gets heated and kind of left down. Because you can't print kind of out of thin air, as it's kind of explaining right there. And then there are rafts, which is a technique to prevent warping. A flat layer of support material is printed below the 3D part. As the raft is larger than the part, is better adhesion. Once the 3D print is finished, the raft supports are discarded. So sometimes in specific programs, whenever you're making a 3D model and trying to print it out, that a raft is also an extra support layer along with the support material that is added, so then prints don't come out lopsided or comes out wrong, or and then sometimes when it hardens, it's easier to kind of pull off. And like I mentioned before, where if you use dissolvable filament, that you can throw it into warm water and then you can kind of melt the part, and then it'll just kind of melt away, since it's plastic, a specific type of plastic actually, that you can actually get the part off. It depends on what kind of thing you kind of use. And then there is the print bed, which is a surface of the 3D printer on which the 3D print part is formed, also known as the bed or build plate. So what that means is that in any 3D printer, you'll see a print part on the bottom part. And then usually when you print something on it, it needs some kind of base for it to actually print onto, that has like a thin kind of blue tape material, or it's rubber, that this way the thing doesn't get stuck, the print doesn't get stuck to what kind of material or a table or whatever, so then it'll be easier to get off. And sometimes, not sometimes, but all the time, that whenever a print is done, the print bed itself is able to be either slid out or to be pulled up from the magnets. So then this way you can actually easily remove stuff, as we'll get to talk about later on. And then there is the infill, which is an interior structure of the 3D model. To avoid wasting plastic, 3D prints are typically printed with an inner mesh structure rather than a solid interior. The infill is typically expressed as a percentage, for example, 20% infill. So what that means is that infill needs to be there, so then a 3D model can kind of be stable, because if there's nothing in the middle of it, and if it's just hollow, it's going to break easily as it cools down. So then that's why there's an infill. So then this way it stays like a solid object and doesn't have to be broken or anything if it's thrown or dropped or anything. So that's why the infill is there. And you can see right here, the support material has a picture of it, that there's support material to kind of elevate this portion right here, and it kind of elevates it from the bottom. It's like a very thin material, so then this kind of gets raised. And then there's the raft, which is, like I said before, it's a base. So then this kind of thing doesn't come kind of lopsided or kind of off center right here. And then you can kind of break this part off, and then it'll just be this instead of this bottom portion right here. And I talked about before, here's the print bed, which right here kind of looks like a stationary, but in most commercial 3D printers that they're removable either by sliding or there's like a magnet adhesive to it. And then here is the infill, which I talked about before is the density of the interior of the 3D model. So then it doesn't come out just completely hollow. As you can see, there's different kind of patterns here as you kind of move along. And then next, other things that you might need when you're 3D printing, other than the 3D printer itself, is that there is an X-Acto knife. As you can see right here, it makes it possible to kind of cut things specifically. So if you make a more complex 3D model, then instead of having an extra part that you needed to use, instead of trying to break it or something, you can use the X-Acto knife to kind of cut specific portion so then it comes out the way you want it. And then there's a spatula, which sometimes needs to be used to lift something if it's stuck on a surface, like say if you use one of those sliding trays, those sliding bases, and it used the paper, and if the paper kind of gets ripped or breaks off of the base itself, it can get stuck. So then you use a spatula to kind of flip it up, or at least to hold onto the object, and then you kind of lift it up so then it doesn't get stuck. And then there's also neo-nose pliers, which can be used to alter the print or to at least pick off a specific kind of portion of it that you want to take off. And then there's glue that you could use to, sometimes there's specific glue that you have to use to paste things if they're thin enough to allow them to kind of stick to each other, as well as painter's tape. So with painter's tape in this kind of instance is that you could use that to line up. So if you say you want to make an object and then you want to spray paint it or something, or to mix two different colors, and you can kind of use the tape to kind of go around so it either doesn't get stuck or the paints kind of mix. And then for ABS filament only, you have the polyurethane, which is what you see right here. It's kind of like a varnish. And what can I make, you may ask? Usually with 3D printing, it was originally designed as a way to make prototypes. So anything you can think of from the beginning of commercial use, for instance, if they're using for action figures, or say, if you want to make a stop motion video or like stop motion movies, a lot of times they were used to have 3D printed kind of prototypes like you see in CG stop motion movies. Like if they weren't using puppets like Nightmare Before Christmas and stuff like that, that they actually use 3D printers to kind of create like prototypes of it to actually use, see like what characters would kind of look like as like a base for it. And then you can also make whatever you like, whether it be toys like I mentioned before that were made to use kind of like Transformers and kind of stuff, or you can make keychains. You can kind of create a hole on the side or whatever, and you can use that to make a keychain. And then you can also make tools, specific ones, so you can 3D print, like, it's not going to be hard enough to where it's going to be unbreakable, but you can kind of make a replacement part too, where if you need a screw or something, you can actually use stuff that we even have here. It's like a replicator that you can take like a screw if you don't have enough, and then you can scan it, and then once it gets loaded into the program, it creates an exact replica of whatever you make, so that you can make a replacement for something if you don't have an extra kind of piece for it. And then what have others made? People have made small replicas of like houses, they can be used for prosthetics, replacement parts, like I mentioned before, and sculpture. So kind of going by each one singularly, that you can make kind of replacement parts as far as, like I said, there might be a screw, or there might be a wash, or there might be a, I'm trying to think of the name. But what you can do is that, like I said, you can use a digitizer, or if you're skilled enough, you can actually create an exact replica of something. So if you need an extra part for something, and then you can replace it. And then with prosthetics, you can actually make prosthetic kind of hands or legs, something like that. If the material is strong enough, you can actually do that sometimes. It's not recommended, but you can use that sometimes instead of using or having to buy specific prosthetics that are made elsewhere. And then for houses, you can actually make kind of either replicas or stuff like that, to where it kind of looks a bit realistic from that kind of stuff, and also as well as the sculptures. So with that, you can actually, like I said before, where you've seen kind of like 3D model prototypes of kind of action figures or toys or something like that, you can kind of create sculptures as well to kind of match it with that. And then in creating your 3D design, like I mentioned before, there's Thinkorcad, Sketchup, and then Blender. So each one's kind of a different level. So I'll show that later on and show what the websites look like. So then you kind of get a feel for it as far as like your ability to use specific things. And that's it as far as the PowerPoint presentation. And right now, and right here, my name is Joe, and I'm an IT2 at the Orland Park Public Library. Here's my email for if you need to contact me or anything about any questions beside what I can answer right now, and as well as the number to the help desk that's out here. So I'll leave this time to be open for questions, and I'm also going to show what the other websites kind of look like, so then everybody kind of gets a feel for what you can kind of see right here. So then let me kind of get in here. So when I go to back to the slide right over here, I'll load up these specific websites. Let's go to Thinkorcad. And I'll leave, like I said before, I'll leave this time open for any questions that anybody has. So let me just open up a browser right here and go to Thinkorcad. And right here, it's owned by Autodesk, which is a CAD software. And you can kind of start tinkering, and you can also join a class. You can kind of host stuff. And then you have free lessons. And then it says right here, Thinkorcad has create, design, make anything, program, simulate, and assemble, design with code. So you have 3 different kind of options. And then there's a video right here explaining how it works. You can see what you can make. You can use a brick builder, Minecraft modeler, plant pots, like kind of different kinds of examples. And then get started. It's free, nothing to download. So easy start is ridiculous. It's basically free to use as it's mentioning right here. You see the about and stuff like that. You can kind of follow some stuff. So then if you say start tinkering, and then it'll ask you if you're in school or if you want to create your own personal account. So if you want to create your personal account, you sign up with Google or an iCloud account or with just regular email. And then as you kind of go through it, since this is more for beginners, that it'll easily kind of help you kind of get into the mix of it. All right, and I got my first question. So how long have I used 3D printing? For me, I've mostly been using 3D printing for stuff like keychains, or sometimes I needed a replacement part for something that didn't have enough screws or something like that in it, like a box of, like, if you're trying to assemble like a chair or desk or something, I've used that for replacement kind of parts. And then at the library, you can actually submit these STL files to ask at maker@orlandparklibrary.org, or kind of send it in that way. So then you can create your own if you don't have a 3D printer, and you can kind of submit them as kind of like project files, and then we'll print it for you with one of our 3D printers in the building. So as far as working with that side, I've submitted a lot of people's prints and had that kind of extra footing right there. With the scale of the object, we have two 3D printers. We have a Makerbot that's very tall. Show like an image of it right here. Makerbot 3D printer. To give a more visual representation of it, it looks exactly, there's two of them. One of them kind of looks like this right over here. You kind of see it's a little bit smaller, but then we have a taller one that looks exactly like this, where it's more like the taller objects, which is called the Makerbot Method. And I'll kind of bring this up right here. Let this load up. So then you can kind of make a bit of a taller kind of object, as you can kind of see right here, what you can kind of make right here. So you can, with our Makerbot Method, and if you get one for yourself, that you can make bigger objects like you asked, where you can make a smaller lamp, nothing too big, but kind of big enough to at least like this kind of height, as well as shoe, depending on what kind of support you're using, or when you're using a raft, or how kind of big the object is. So then this way you can kind of use that. And with that, you can actually create something like that. So then next would be Sketchup for the immediate users. You're very welcome. You're very welcome, Will. And next is Sketchup for the kind of immediate users. If I kind of throw it in over here. Let me try to fix that. It might have been, all right, yeah, here we go. This is SketchUp. This is more for immediate users that kind of get the general idea of how it works, but then isn't for the advanced users that kind of can't really find their way around it completely. So as you kind of see right here, it works just like the last one does, where if you kind of click right here and try SketchUp, you can kind of see where it kind of offers a 30-day trial, which gives you the desktop client and the premium web modeler. And there's 2 documentation and a VR model viewer. So then when you start up from here, you have to sign in, then it kind of walks you kind of through it from then on. So it's fairly much the same, but now instead of it being in browser, it's using a desktop kind of client itself to where it's like a program, but it's kind of offloaded of the browser. As you can see right here, it gives you kind of visual representations and kind of gives you kind of like a brief kind of overview as far as like the dimensions, the cost, quantity, as far as like what you can make. And then you can see right here on the bottom where you can see like kind of scale model like you would see in like film, if you see like something like a Harry Potter film, whatever, when they have like 3D modeled kind of things that they don't have enough space kind of to create the movie with, that you can kind of see that as like a basis to see how big kind of the area is. So you can kind of use that for stuff like that. And then right here you have prices and planning. I got another question about if the library provides or if people can bring their own. With that, we provide our own. You can't bring in your own filament, but with ours, we have a set amount of stuff that we have on hand, whether it be dissolvable filament or the regular stuff, where you can either submit or you can kind of bring that in and you kind of make it your own. And then there's also different colors downstairs too that you can choose. We kind of bring up here or whatnot, where there's either greens, blacks, either it can be transparent or opaque. So it kind of gives that kind of idea of what kind of options you have as far as what you can do with that. And as you see right here, you kind of see different plans from this site you kind of use. So there's always that. As far as quantity, can't think of the top of my head how much we actually do have, but for colors, we have black, we have clear, we have white, there's green, blue, light blue, dark blue, teal, orange, stuff like that. So we have a fair amount of the types of colors that you would normally want to look for. Pink, I'm not 100% sure. I don't believe we do have pink, but we do have the vast majority of the regular colors that you would normally want to find, like red, green, blue, yellow, white, black. So as far as that, I'm not 100% sure as far as what kind of specific colors. I'll kind of get back to that in a bit. And then I'll show off Blender. If you can use two different colors, as far as I know, you can't like unload and preload and then add two extra colors on top of it. Like if you're gonna print something, it's either gonna be in that one color or not kind of deal. So as far as I know, I'm not an 100% complete expert on the subject itself, but as far as mixing two colors, no, because sometimes if you try to unload a filament, you have to kind of load in another one and then have to have the thing cool down. So as it's kind of starting, there's not really an option for it to actually stop and then having to mix two colors, because sometimes if you're using something that's dissolvable and then something that's not, it doesn't really mix well as it's being printed. So that's the kind of factor you kind of need to factor into what kind of thing you're making as far as that kind of thing. And then here is Blender, and this is more for the professional eye. You're very welcome. And then here is Blender, which is for the more professional. As you can see, there's different kind of options right here. So what Blender is, it's more really used for is game development, which I've known it to be used for. So for instance, when you see these CG movies, or if you're playing PC games or console games, a lot of people do use stuff like Blender to assist in video game development. So that's more of the advanced side of it. So you have the option right here to download Blender. And then you kind of see a little bit of a blog and stuff like that on the bottom right here. And as you can see right here, you kind of modify stuff live if you want to make a CG movie or a short film, or like I said before, with game development, that you can kind of either hand draw or make a 3D model in the program itself after you download it. And then you can kind of make your own kind of little project, whether it be animation or something like that, where you can kind of make things kind of like, it's kind of like a video editing software, but minus the video editing part, where you can kind of make things kind of as you kind of go on. So that's what more or less of what Blender offers as making 3D modeling and whatnot. And like I said, with stuff like this, there's many different fields as far as what you can make and what each kind of program allows for in that kind of realm. So with that, that's fairly much it. So let me just go back to the last slide right over here. And that's very much it as far as the ins and outs, but with the extra stuff at the end, that each kind of program or web assisted kind of program, that it gives you different kind of options based on your either skill level or with what you specifically want to do as far as what kind of thing you kind of make. And as far as with that is what you can do with 3D printing too, is that you can either, once we open up the text center to actually add some stuff, you can actually make stuff in-house, or you can submit stuff through our email with the maker@orlandparklibrary.org email. So then if you're not extremely savvy yourself and you want to create something without needing to first say make it, where if you don't have something that disposable, you can actually send it in and then we can do it ourselves. Yeah. And with that, you can actually say, if you don't have the 3, 4, 5 grand laying around to have your own 3D printer sitting at your home, whatever, that's why we offer that option. So if you have the finesse to make your own 3D object with the program itself, or there's other types of programs you can use that aren't mentioned in the PowerPoint, that you can, like I said, submit it through and then we can print it for you. So then you don't have to worry about having that kind of device kind of sitting around your house if you don't have the money or the space for it. How much does it cost to print from the library? So with that, we have a very straightforward pricing option to where I believe it's per gram. It should be 10 cents per gram. So if you print something out pretty big and it's like 23 or 24 grams, that'd be $2.30 or 40 cents. So if you kind of think about it, if like per gram, you add kind of 10 cents to it. So if it's 1 gram, it's 10 cents, two is 20 cents. So then it goes kind of up to, say, if it's like 100 grams, that's huge. But as far as like the kind of option you kind of have right there, you have it'll be like a $10 mark. So it fluctuates as you kind of get higher and higher. So with that, it's, to answer your question, kind of finally, it's each gram is 10 cents per gram. So if it's a gram, 10 cents. If it's 100 grams, it's $10. So that's what the pricing is for that. You're very welcome. So I'll leave this spot right here to be more open for questions. Anything else that needs to be answered, if there's anything else that I didn't go into well enough, or if there's anything that needs to be clarified that I described before. So I'll leave that kind of to be open. But with 3D printing, I think it's a very unique and very cool thing to do, because like I said before, where there's people that want to, say, make like an ornament, like right now with Christmas coming up, where you can make an ornament from a 3D object instead of having to go out and buy something. Or if you're wanting to make something for someone that's very unique that isn't sold, you can make your own. And then this way you can kind of have your own kind of personal touch to it. And with that, you can actually, with sending prints, it has to be sent through maker@orlandparklibrary.org. Because if you send to mine, if I'm not working, or as like a standard, you cannot send it to my personal email address. It's got to be sent through maker@orlandparklibrary.org, to clear up that question. But as I was saying before, that it's a very unique thing to where you can actually create anything, no matter if it's very tiny, like a piece of like screw or something that's missing, or something as big as, like I mentioned before, you can make prosthetics or sculptures that are very high or very short, or say a replacement part, or at least like even a bracket, like I've seen before where people have made kind of headphone brackets. If you need something to kind of hang on or with headphones, or you can actually make a replacement part for a piece of headphones. So I've seen before someone's asked to print a replacement head to the part of a headphone where it connects from the base of the ear to the top of the head. And you can actually use that as solid filament. So then if it's, say, printed as like a base, you can throw it into some hot water, and then this way it'll get rid of it. So then it'll just be that exact portion of it, so you can actually put it in. And then also at the library too, that we offer is that there is a Makerbot digitizer. So what that is, to clarify, is that you can actually, say, if you want to make something to an exact T and you can't think of the dimensions, you can bring in something like, say, if you want to make a 3D model, like a pencil, or if you want to make something like a replica of like a bottle of whiteout, or like I said before, where if you want to make something that needs to be a specific dimension, like you can take in the broken part of, say, the part of the headphone or a case or whatever, and you actually 3D model it kind of on it. So there's that option right there. I mean, with prosthetics, it is possible, because once it hardens, depending on what kind of material you use, you can actually make live prosthetics for, like, say, arms, legs, stuff like that. I wouldn't recommend it, but it is indeed possible. So there's that kind of answer right there. I'll leave this a little bit time left to, I'll leave about a couple minutes at the end. At the library, with the biggest 3D printer we have, that you won't be able to make something that big as far as if it's a long arm or a leg, but there are more expensive options of 3D printers that you can actually make bigger prosthetics. If it's something like a part for it, for example, like what we have right here, you can make different types of replacement parts as far as like a joint or as far as something to twist or something, just something smaller, nothing as big as like an arm, but you can make like even a hand, probably that'd be much more of like a realistic scale as far as what you can make with the size that we offer right here. As far as teeth, like I said before, it is possible, but not recommended. I would, as far as like a tooth, I would go to a dentist before I would actually make a 3D model for a filling. It's not exactly, like I said, it's not recommended, or is it safe to do so without it being done by a professional? It's not like saying, oh, well, I can use a filling with a 3D model. No, you can't. It's not recommended. It's like a thing where it's, you can, but you shouldn't kind of deal. You're very welcome. You're very welcome, Dan. And with this last question right here, what plastic can be printed, 3D printed, is it fairly soft? With that, you can actually say, like, I've seen before where you can make, like I said, replacements for like the filament itself. Once it gets extruded and cools down, is strong, but it's not, as far as the scale of what you make is strong enough to support, like, if you want to make it's possible if you have something big enough like a TV stand or something, but it's not recommended to make something that kind of built quality per se. But with that, you can actually make replacement parts for like TV stands or something like that. That's that kind of weight to it. And with the plastic itself, like I said, it's fairly dense depending on what kind of filament you use and what kind of infill it does have. But there's that kind of answer, if that kind of answers that question. Okay, I'll leave it for about a couple more minutes and then I'll wrap the class up in a bit. So if there's any more questions, just feel free to drop it in the chat. And like I said before, if there's any more questions after the class is done, you can actually send it via my email as I list right here, or you can call into the help desk. I'm usually out there majority of the time, that, or someone else that's also at the desk at any time should be able to answer your question for you. Okay, I'll leave this for a little bit longer if anybody has any questions. And yeah, that's fairly much it with the introduction to 3D printing. So at first glance, this concept sounds very complex, but there are a lot of resources on platforms like YouTube, or just coming into the library or and asking the IT department if there's anything that you need to answer as far as how it needs to be sent, how big of an object, what kind of colors and stuff like that. So you have those different kind of options to make it easier for you to not feel in the dark as far as how this kind of stuff gets made or if you can actually make it. So there's that kind of ending part right there. Well, looks like it's about time. So this was an introduction to 3D printing. If there's any more questions, you can leave it, like I said before, at this email or phone number right here. And my name is Joe. I'm an IT2 at the Orland Park Public Library. You can stop by if you have any questions for this, or like I said before, anybody in the IT department can help answer your questions. So that was an introduction to 3D printing, and thank you for watching.